On the left of this screen is the graphical interface you use every day to manage a personal computer. On the right is the stark, text-only terminal required to manage a production server. Production servers do not waste resources running graphical user interfaces. When a server environment suddenly slows down or crashes, administrators must diagnose the issue entirely through this command line. To perform these diagnostics, you need exactly two things: an open terminal application and an active, logged-in session to your Linux instance. Learning to operate without a mouse and visual folders is the only way to communicate directly with your operating system during a crisis. The immediate danger of a text-only environment is losing your place. Without visual folders, it is incredibly easy to get disoriented in the system architecture. This terminal shows the execution of PWD, which stands for Print Working Directory. When you log in, typing this command outputs your exact coordinates on the system map, so you know exactly where you are starting. Once you establish your location, typing the ls command lists the hidden files and folders contained inside that current directory. You can expand that basic list into a comprehensive inventory by adding a flag. Typing ls space -ltr displays detailed properties, including when the file was created and who owns it. Looking closely at the left-hand column of this output, you can decode the file types. If the line starts with the letter D, you are looking at a directory. If there is no D, it is a standard file. Establishing orientation is your first priority. You cannot reliably navigate the server until you know your current coordinates and the contents immediately surrounding you. To move inside one of those listed directories, type cd, which stands for Change Directory, followed by the folder name. Linux file systems are strictly case-sensitive. Capitalizing a single letter incorrectly in your command will result in an error and block your access. This flowchart illustrates Linux navigation. Execute cd to step into a folder, then immediately run pwd to verify your new location. To reverse course and step one level up the hierarchy, type cd space ... The entire file system is constructed as a strict branching tree. By combining these directional commands, you can reliably reach any file on the server. After you locate your necessary files, you will often need to assess the server's health. You must evaluate memory, processing power, and disk space without graphical performance gauges. This terminal mockup shows the free command, used to check your system's RAM. By adding the -m flag, you force the system to display data in megabytes, and the highlight shows exactly how much memory is currently available. Next, running the nproc command will immediately print the total number of processing units available to the machine. This split screen compares disk usage commands. On the left, the standard df command outputs a confusing wall of byte-level numbers. On the right, adding the -h flag converts data into readable gigabytes, and the arrow points directly to the total percentage of disk space used. If you need to monitor all these metrics simultaneously in real time, you type the top command. This generates a live, continuous feed of system performance. This static view breaks down the top interface. Dimming the process list below lets you focus on the top two rows, providing the immediate CPU and memory percentages needed to diagnose bottlenecks. Because this monitor updates continuously, you must actively exit it to run your next command. Pressing Q or Ctrl-C will terminate the feed and return you to the standard prompt. System metrics are useless if you cannot parse them. Applying the correct flags and isolating specific rows turns a flood of raw data into targeted diagnostics. You can now log in to a headless server, orient yourself, and interrogate the operating system's hardware status directly. This list represents your functional diagnostic toolkit. With these 7 commands, you can read the complete state of the machine. The next logical step is moving from passive observation to active notification. You will use commands like mkdir, touch, and vi to construct folders and edit text files entirely within the terminal. Evaluating the server's current condition establishes your baseline. Your ultimate objective is writing the direct instructions